Hi, welcome to the current affairs, the part 1 of current affairs of week 2. In this video, we will be looking at Aditya L1, space observatories, and some relevant details about the same. So please pay kind attention to it, and it is very important that you remember most of it. Aditya L1, you can see the image over here. It is India's first space-based observatory to study the sun. Now you have to pay special attention to the space-based part. Why? Because India also has Astrosat, which was launched in 2015. And what is it? It is India's first dedicated space astronomy observatory. Space astronomy observatory. Okay, so you need to know that Aditya L1 is space-based observatory and Astrosat is a space astronomy observatory. And ISRO launched Aditya L1 from Sriharikota. Now let's have a closer look at Sriharikota. Where is it situated? See, over here you find the state of Tamil Nadu, right? And over here you have, to the north border, you have Andhra Pradesh. So you could say that this place is near the border. And see, this is a larger image. See, this is the border between Tamil Nadu and Andhra Pradesh. Over here you have Andhra Pradesh, and over here Tamil Nadu. And you can find Sriharikota here. This is very interesting because you can find the Pulicat Lake here, and you find that the Pulicat Lake is separated from the Bay of Bengal. This over here is the Bay of Bengal, this big body of water. So Pulicat Lake and Bay of Bengal are separated by this landmass of Sriharikota. And this becomes what? A barrier island. Barrier island is when you have sand deposits caused by the waves. The waves of the ocean, they just deposit sand and sand and sand, and over time it develops into an island. That is what this particular landmass is. And this sand deposit is always formed as a parallel to the main landmass. You can see that they are kind of parallel, right? Yes, that's it. Now let's have a closer look at it. The details. Sriharikota is a barrier island off the coast of Bay of Bengal, and it is located in which district? Tirupati district in Andhra Pradesh. It separates Pulicat Lake from the Bay of Bengal. You've seen that already. It houses the Satish Dhawan Space Center. It is named after the former ISRO chairman Satish Dhawan. So this is named after him. However, we need to take note of one thing here. India has two satellite launch centers. One being the one at Sriharikota, and it houses the Satish Dhawan Space Center. The second one is Tumba Equatorial Rocket Launching Station, which is situated at Trivandrum. And coming back to Sriharikota, it has two launch pads from which rocket launching is done using PSLV and GSLV. PSLV standing for Polar Satellite Launch Vehicle, and GSLV for Geosynchronized Satellite Launch Vehicle. Now, why Sriharikota? Firstly, because it is near the equator. For any rocket launching purpose, it is best if it is near the equator, so that the Earth's rotational energy is maximum that is because the Earth's rotational energy is maximum at the equator. We'll have a closer look at that, don't worry. The second reason, first one being that it is near the equator. Second, it is on the east coast, which facilitates the launching of the rockets in an easterly direction. Rockets are always launched in the easterly direction. So you need to take note of that. And for that, it is very important that any launching happens on the east coast. You might have noticed that even when other countries do rocket launches, they always do it on the east coast, be it of the continent. Do you understand? Near a body of water. So east coast and near the equator. That is why Sriharikota was chosen. Now let us see why it has to be near the equator and why it has to be on the east coast. See, as you can see, the earth rotates from west to east. It is constantly moving in that direction. So if you need to send something into space, or if something needs to take off from earth, it would be easier to send it off in that trajectory only. See, it's going from the earth is going from west to east, so it is easier for a rocket to launch itself from earth and go in the easterly direction. So better for things to be on the east coast. Or just imagine that if you have the launch is happening from the west coast and the rocket is going towards the eastern direction. So it may so happen that if the launch is not that successful, then what can happen? The crash can happen in populated areas, which can lead to large casualties. So to avoid all that, they go and launch it at which place? The east coast, so that if at all some crash or something happens, it happens above water and there are no casualties. Now, why equator? Now we have sorted the issue of why it has to be the east coast, right? Now, for instance, over here you can find that Florida. This is Florida. In US, when they do launches, they mostly do it from Florida. So you can see over here again, it's the east coast. Now, coming to the first problem, why is it important that it has to be close to the equator or near the equator? Why? Because see, if a person is standing near the equator, you can see that due to the revolving nature of earth, a body moves at the speed of 61,670 km per hour. And that same person, if that person moves midway up, he kind of has traveled only 1100 km per hour, his body. And if that person is at the pole, has his body faced any sort of displacement? No, it's fixed, 0 km per hour. See, if this has become confusing for you, I can give you a better example. Just imagine that you've taken a cricket ball, and जो बीच में stitch किया हुआ part है, that is your equator, and you're holding that in the middle only, and you're keeping your fingers at the top and the bottom end of it, and you're just turning. You have placed one bindi or you put a spot near the equator, and you're turning the ball. उसी axis को मतलब जो दो fingers से पकड़ा हुआ है उसको ऐसे ही पकड़ के you're turning the ball. So the point that you put near the equator, near the midpoint, it has traveled the most because वो और बड़ा सर्कल में ट्रैवल कर रहा है, राइट? उसके ऊपर अगर थोड़ा और ऊपर होता तो थोड़ा कम डिस्टेंस ट्रैवल कर रहा है वो डॉट. And if that dot, you were to place that dot at the places where you've kept your fingers, वो तो poles हो गया, वहाँ पे है तो वो कहीं move हुआ है? No, it has not moved at all. So it has moved at 0 km per hour. And if something is near the equator or at the equator, that body or thing gets displaced by 1600 km per hour due to the movement of earth. So because of that, you can imagine that this is a huge speed, and ये thrust जो है ये इसी direction में जाने वाले चीज को मिल जाएगा, तो it helps it along. If the rocket launching were to happen somewhere around here, उतना force due to earth's energy उतना नहीं मिल जाएगा. See, what did it say? It said earth's rotational energy is maximum at equator. So to utilize this energy of the earth, which is there for free, or else you'll have to just power it up with even more and more fuel, or you need to come up with the necessary technology for it. So what is best? You can launch it from near the equator. So I hope this is clear to you. So it has to be near the equator and it has to be on the east coast. Now, this spacecraft, the one which carries Aditya L1, it will be placed in a halo orbit around the Lagrange point 1 of Sun Earth, which is about 1.5 million kilometer from Earth. So you need to be aware of this. First thing, that it will be placed in a halo orbit around Lagrange point L1. That is important, and that is around 1.5 million kilometers away from Earth. It would take more than 120 days for the spacecraft to reach L1. Now we will have a closer look at L1. Why L1? What is it? We know that it is called Lagrange point, right? The Lagrange point is named in honor of Italian-French mathematician Josephine Louis Lagrange. And there are 5 Lagrange points in total: L1, L2, L3, L4 and L5. The first 3, L1, L2 and L3, are considered unstable, and the other 2, L4 and L5, are considered stable. Let's have a look at them. See, this is your Sun, and this clearly is your Earth. The points that we said are unstable are these: L1, L2 and L3. The stable ones are L4 and L5. See, these are not, it may look like they are fixed positions in space, but they are not. Their position, it depends on the position of Sun and Earth. The Sun is stationary, so you can imagine that it differs with the changing position of the Earth. For example, if Earth were to move here, then all these positions would tilt by so much. Then if this is where your Earth is, your L1 might be here, your L4 might go even further, your L5 will move to this side. I hope you get my point. And behind the Earth would be your L2, and your L3 should be somewhere around here. Now, what is so special about these points? The Lagrange points are positions in space where objects sent there tend to stay put. Matlab, if we put an object there, it is not going to move around a lot. No, it is going to stay in that particular place only, which means that it is not necessary to spend more and more energy to keep the object that we want at one particular place. So it can be more fuel efficient to keep the object in the Lagrange point. And how does it happen? How come at the Lagrange points the objects sent there tend to stay put or tend to stay stationary? How? That happens because of the gravitational pull of 2 large masses. The 2 large masses in this case are see, यहाँ पे Sun, and over here this is your Earth. The gravitational pull of 2 large masses precisely equals the centripetal force required for a small object to move with them. So a small mass can orbit in a constant pattern. A small mass can orbit in a constant pattern with 2 larger masses. And the mathematical problem is known as general 3-body problem. You need to be aware of this term at least. The general 3-body problem is the basis of your Lagrange points, and Aditya L1 has been placed at L1. Why is this relevant? These points in space can be used by spacecraft to reduce fuel consumption needed to remain in position. We've already mentioned this. So if you keep your satellite over there, it will save you fuel. Now, let's have a look at this. What is happening over here? What do you mean by centripetal force? Just imagine that there is a central point and एक radius है, उसी से this is your central point, and this is moving. A certain something is moving around it. When this movement happens constantly, what happens is that there is this force, अंदर की तरफ एक pull है, जो अंदर की तरफ मतलब ये जो बीच में सेंट्रल पॉइंट है उसकी तरफ एक पुल है. एंड दैट इज हैपनिंग बिकॉज ऑफ द प्रेजेंस ऑफ दीज टू बॉडीज. एक तो ये सेंट्रल पॉइंट होके वर्क कर रहा है एंड यू हैव अर्थ और द अदर थिंग विच इज रोटेटिंग अराउंड इट, एंड ये बीच की तरफ एक पुल है. तो ये जो ग्रेविटेशनल पुल है ये जो दोनों मासेस का है, सन एंड अर्थ का है, what happens is that this kind of helps an object which is placed over there, over at this place, to stay constant. उसका position kind of constant हो जाएगा because of the gravitational pull of these two objects. I hope this is clear to you. Let's just move ahead. Now, why L1? L1 do you've seen? L1 is between the sun and the earth. Is there an obstruction in the view? No. If it were L2, you can see that there would be some sort of shadow with the observation because beach mein you have earth. So you will have to observe the earth as well as the sun. In this, कुछ भी eclipse या ऐसा कुछ होने का chances नहीं है. So at all times you can observe the sun. The satellite placed on the halo orbit around the L1 point has the major advantage of first, continuously viewing the sun without any occultation or eclipses. Occultation means the same, where, see, for example, if the moon is blocked by some other view, तो उसकी वजह से इतना ही दिख जाएगा. Does it mean that the moon is only so much? No, the moon is so much. तो what they're trying to say is that ऐसा कुछ eclipse या view जो distorted होने वाला case है, that will never happen if we keep the satellite at L1. Second, it will provide a greater advantage of observing the solar activities. Greater advantage of observing solar activities and its effects on space weather in real time. It's closer, so it can happen in real time, all these observations. Now, we need to know that we are already keeping Aditya L1 over here. But यहाँ पे at L2 we already have what? The James Webb Space Telescope. This is very popular. James Webb Space Telescope is already placed at L2. Currently, an artificial satellite called the Deep Space Climate Observatory is located at L1 to study solar wind coming towards Earth from the sun and to monitor Earth's climate by taking images and sending them back. So what is the point of Deep Space Climate Observatory? And that is, see, mind you, this is located at L1. We are sending our space telescope to the same location. So this Deep Space Climate Observatory, what they do is, first thing, they study solar wind coming towards Earth, and second, monitor Earth's climate. The Deep Space Climate Observatory, if I remember right, does not come under the purview of one single country as such, but there is a prominent US contribution or presence in it. So you don't need to look into the background of this as such, but you need to know that this thing which is doing these functions or which has these goals is already located at L1. Now, space observatories. So you see, right now we've heard that okay, India is going to send we're going to have a space observatory. We are going to observe space. We are going to look at the universe from, or the sun from space. Why space? Is it an entirely new thing? No. NASA and other space agencies have been flying space observatories of one type or another since the late 1960s. So you can imagine around 60 years से ये already चल रहा है. India is a bit late in catching up, that's all. One of the prominent things has been the Hubble Space Telescope, which was launched in 1990. So you can imagine how far ahead these countries are as of now. And why space telescope? Is it not possible? Why do you need to have a telescope in space? Why not just observe from Earth? Isn't it more cost effective? No, it has its own advantages. First thing, it is able to operate 24 hours in a day, and it can be free of the Earth's day-night cycle. See, what they're trying to say is that space mein hai, so there is no night and day for the satellite or your telescope over there. So it can observe at any time, Imagine if we had placed the same telescope on a particular place on Earth. और मान के चलो we are doing it at Patna or Delhi. Once it is night at Delhi, it means that we are facing away from the sun. So it is not possible to observe the sun at night, right? So we are wasting valuable time. We will have to wait till daytime to observe the sun again. So it will limit our potential. So first, it will be free of the Earth's day-night cycle. Second, the clouds and other weather conditions that can hamper observing. If we were to place that telescope on Earth, what if it's a very cloudy day? It is impairing our vision. Such things can be avoided when you keep the telescope in space. Then another additional thing is it can observe portions of the electromagnetic spectrum of light, such as UV radiation, X-rays and gamma rays, which are blocked by Earth's atmosphere and never reach the surface. So if you were to keep your telescope on Earth's surface, it is not possible to study or observe the electromagnetic spectrum of light, such as UV radiation, X-rays and gamma rays. This is your third advantage of space telescopes. Now, fourth, they are free of the distortions in the atmosphere that blur images. Distortions in the atmosphere, it can be your aeroplane, it can be some birds, it can be some other weather phenomenon, it could be anything. So when your telescope is in space, you don't have any such issues, and you can carry on with your work smoothly. You already know this, that AstroSat is India's first dedicated multi-wavelength space telescope and was launched in 2015. So these are the main points about Aditya L1. I hope it is clear to you. In case you have any further doubts about this, please drop your question in the comment section and I will address it at the earliest.